Okay, so as we're really finishing up Module 5 here when we talk about the remainder and the factor theorems. But this is going to be using synthetic division and sort of understanding what is going on with our remainder. And there's a lot of stuff going on in this description here, but what do we know? We know that when we divide f of x by g of x, we get a quotient, and they call it q of x, and then we get the remainder over the g of x, whatever my remainder is. So this is the division process, and then, the quotient and the remainder. And then it says, and that the quotient times g of x is equal to, plus my remainder is equal to f of x. And we're just reversing. It's like a literal equation as we go around mathematically. That division algorithm. So we know that basically what it's going to boil down to, and it's going to work out synthetic substitution is where that a value that we divided by is going to be equal to the remainder. And we'll see some of that in practice here as we talk about it. So if we use synthetic division here, the remainder theorem, I have p of x, which is x squared minus 4x plus 7, and they want when x is 5, so we're going to divide by 5, which would be the same thing as saying, hey, I'm dividing by x minus 5. So as we do this, we have 5 in the box, then the coefficient of x squared, the coefficient of x, and then my constant. We factored down, or we went ahead and did synthetic division, and we came to 1, 5, 1, 5, and then 12 is my remainder. Well, what they're saying is, if I put 5 into the equation, to the polynomial, I get a 12 out. So this is my x in, this is my y out. Now, if we were to test that by plugging 5 into the equation, wherever there was an x, it works out that when I evaluate that polynomial for the value of 5, then it is the output of 12. So there's my ordered pair, 5, 12. So they're saying if you use synthetic substitution or the synthetic division, this is your input and this is your output. So that's what we're getting to here, being able to utilize that. And it's referred to as synthetic substitution. So here, looking at this, because if you were to substitute a value into the equation, it would give you the output. Well, we're doing that synthetically. So here, synthetic substitution using f of negative 3, and this is going to be the substitution, the polynomial I'm going to substitute into. They are missing x to the third. So I need to make sure that I have my 0 placeholder there. So that's why I wrote that out so you can see that. So we have negative 3 in the box, right? And then we have the coefficients. And then we do the synthetic process by adding down, multiplying, getting a 6, add down, multiply, get negative 18, add down, multiply, get 45, add down, multiply, get negative 90, and then add down, and I have negative 81. So synthetic division tells me that when I input a negative 3, I get out a negative 81. That is the process. Now, if we were to check it, that's exactly what we did here. They went ahead and did it, the substitution method, to check it, and they came up with negative 81. So this is a lot, that's easier than typing this into my graphing calculator to come up with a value and look at it on the table. And I would just reiterate here that understanding that this, when I input f of negative 3, if I were to see that, it would be f of x, and that would be x plus 3. If we saw it in that as a binomial. So keep that in mind. Being able to communicate back and forth between these things. So here using synthetic division, I'm going to practice this one real quick. I like this one. So let's go ahead and do this one real quick. And again, I'm going to substitute in -5, so that's my synthetic division. So I have -5 in the box, and then go ahead and practice this and then check your answer. And go ahead and stop. Okay, I bet you didn't stop, but let me see. I'm missing the x to the third, I'm missing x to the second. So I have 1, x to the fourth, x to the third, x to the second, x to the first, and then my constant. So bring down my 1, multiply across, I get -5. Bring down my -5, multiply across, I get 25. Bring down my 25, multiply across, I get -125. Bring that down, I have -131. Multiply across, I have a positive 500, 600, 655. And then add down, and I have a positive 647. So it tells me when I put in, h of -5, I get out 647. And that seems like a ridiculously large number. Something seems like we did something wrong. But check your math. It was pretty simple. All we did was add, subtract, multiply. And what I did was real quickly, I put it into the calculator, and when I put in -5, I get out 647. I assure you that this process was faster than putting that into the calculator. But again, it's just about the practice. Now, if you come over here in this synthetic division, I will just say that they're asking you to do it with 8. So go ahead and, I have 8 that's going to be in the box, and I just want to make sure that you understand that that would be the same thing as x minus 8. We're using 8 to do this synthetic division or substitution, and I'll give you a second. So there you go. If you did it, you can check your answers. I have 8 using, then I have -6, 52, -27, and -31. Bringing down, multiplying across, bringing down, multiplying across, bringing down. Ends up that I have, when I plug in, I ends up with a remainder of 9. So f of 8 equals 9, and that's what we're doing here. This word problem, applying the remainder theorem, it's the same. Excuse me. It's the same process. They just came up with a little bit different numbers, just because we have a different kind of equation. But the total production of eggs in billions in the United States can be modeled by this right here, where X is the number of years since 2000. Predict the total population of eggs in 2025. Well, that would be 25 years since 2000. So since 2000, so my value that I'm going to use for synthetic division is 25. And then here's my coefficient. They have x to the third, second, first. So we have all of our x variables represented. We didn't have to put any spacers in. And then just add down, multiply across, multiply 25 times 0.007. I think that and then so it's 0.175. Add down, you have 0.026. Then multiply across, you get 0.65. Then you add down, you get 2184. And then multiplying across, you get 54.6. And then combining down, you get 553,931. Okay, so in 2025, approximately, did it tell me to round to any certain decimal place? It did not. 139.355 billion eggs will be produced in the United States. Okay, and I will just tell you, I went very slow to do that, but this is the same process. Just because it has a bunch of decimals doesn't make it any more difficult. Okay. Now here, again, the same thing. If I know I'm going to do synthetic division, I'm not sure the ideal weight of a kitten in pounds is modeled by this function. So I have 0.009, 0.127, and 0.377. Where the X is the age of the kitten in weeks, determine the ideal weight of a 9-week kitten. 9. So 0.009 multiply. Let me see here. Let's see here. 1, 8, 0. Oops. Put it in the wrong spot. Then you combine down, I think, 8, 0, 2, multiply. You get 1.872. Let me check that. That looks right. So this is 1.872. So we come to what? 2.249. We could say that's 2.2. Somebody might turn around and say, well, this rounds up to the 5, and that would take this up to a 3. So 2.3, 2.2 or 2.3 pounds. So I guess it just depends on where you opted to round. So with that, the factor theorem. Now, the factor theorem is it a factor? Is it a factor means that it's going to be equal to 0. So anytime that we see a remainder of 0 means that that is a factor of that polynomial, because it is whatever the input is 0, so that turns out to be one of my x-intercepts or my solutions. It's a solution. So if I divide this, show that x plus 8 is a factor of that, then find the remaining factors of the polynomial. In order to do that, remember this is the same thing as x minus a negative 8. So that's why we are synthetic division with negative 8. And so in doing so, you carry down your 2, you multiply 2 times negative 8, then you have a negative 1. Negative 1 times negative 8 is a positive 8. Then you have a negative 3. Negative 3 times negative 8 is 24, and then we have a 0. So we know that since the remainder is 0, x plus 8 is a factor. So I know that I have x plus 8 is a factor, and then the quotient is 2x squared minus x minus 3. And now we have to ask, is that, and of course, I guess they say here, there's my word problem, or my vocabulary. This is the depressed, sad and depressed polynomial, because it is it has lost a degree. Now you have to ask, are we done? This is a factor, and it asked us for the remaining factors, and we have to say, hey, is there a way for me to factor 2x squared minus x minus 3? I say yes. Okay. Going through the process, we might find out that 2x times x is 2x squared, and then what could I do with negative 3 being either negative 1 and a positive 3, or a positive 1 and a negative 3, that would allow me to have negative x when I combine like terms, which I guess it would be something along the lines of that. So then, knowing that these are now my factors, that, and that are the actual factors of the original polynomial. So this is factored form right here. This is standard form of my polynomial. So using synthetic division makes it really easy to factor too, or also. So keeping that in mind, if I were to find this and do it here, but what are my solutions? My solutions, of course, would be x plus 8 equals 0, 2x minus 3 equals 0, and then x plus 1 equals 0. So x is equal to negative 1, x is equal to negative 8, which we already figured that one out. And then, of course, if I add 3 to both sides, 2x is equal to 3 dividing by 2, and x is equal to 3/2, or 1.5. Okay, so there you go. Working with those. that factor theorem is very beneficial. Understanding the premise behind it, solutions. And then here it says in this example, and I would go ahead and feel free to do this, stop the video and give it on your own. And most of you probably didn't stop it, but it says select all the factors. Okay, once you find one, let's see, not sure. We could pick one. You just pick one and check it. Right here, synthetic division, x is minus 2, I would use positive 2 into the synthetic division. I would use synthetic division and I would have 3, 10, negative 27, and negative 10, and see what is my remainder. If my remainder is 0, it's a factor. Bring down my 3, multiply across, bring down my 16, multiply across, bring down my 5, multiply across, 10, 0. So it looks like since my remainder is 0, this is a factor. And then that leaves behind 3x squared, because it's depressed. It used to be x cubed, now it's only x squared, plus 10x minus 27. So now you can factor this again. You could pick another one. Let's look at B. That would be synthetic division for negative 5. Negative 5, and I can just use the depressed, the depressed polynomial, and that would be 3, if you can't factor, right? If you can factor, you're done. You could figure it out easier, because if you can factor a quadratic, you know how to do it. But bring my 3 down, multiply across, I have negative 15. Bring my negative 5 down. That's funny. Look what, did anyone notice what I did wrong? This is a 16. This is a 16. And then this is a 1. Definitely make mistakes. Definitely been known to make mistakes. Definitely been known to make mistakes. So I bring down my 1, and then negative 5 times 1 is negative 5. That is 0. So it looks like 3x plus 1 is also a factor. Well, that's my depressed, right? That's the depressed one. But I used synthetic division with negative 5, so that is a factor. And then I only have one factor left, which is right here. So that is one way to do it. You just pick a factor and go with it and get a starting point. We just happen to luck out and find the first one. And with that, I would encourage you to do this one. Again, doing it the same way, trying to figure out what are all my factors, and we're going to start with a factor of x plus 2, which means I'm going to use synthetic division, negative 2 in the box, right? The opposite. So if you do this, we find out that yes, this is a factor, and if you'll notice, I end up with so my factors would be x plus 2, and then I have x cubed minus 8, which if you recall is a difference of cubes. So I have x plus 2, and then I have what? X minus 2, and then x squared plus 2x plus 4 is my other, remember, because this is, I factored the difference of cubes there. So now those are my 3 factors. There's nothing more to be done with that. I'm not asking you to go on with the quadratic formula, but there you go. Those are 3 prime factors that we could have done. So with that, we'll just go ahead and do our assignment today and see how it goes.